Does everybody have their review sheet out? So we're going to go over the review sheet today. Your test is tomorrow. Some of you I know won't be here tomorrow, so your test will be on Monday, because Monday will be the vocab for the next chapter. Friday, Thursday, Friday. I'm not going to be here Friday. I'm going to be on the academic trip. So, yeah, so then we wouldn't be here anyways. So, we're going to look through these here so that y'all are ready for your test. Now, are there any questions on 1 through 4, or one of those that y'all want to look at in particular? So if we look at number 4, the first thing we want to find is the scale factor. And when we look at the scale factor, we're just trying to see what is the proportions from one side to the other. So we just need to pick one of the side lengths on A, B, C, D, or E, F, G, H to go first. So we could pick, say, 6 from A, B, C, D, and its corresponding side is 8. Now we just need to reduce 6/8, so we could plug that in a calculator for it to reduce. And this would reduce to 3/4. So the scale factor for number 4 is 3/4. So that's all we would need to find for the scale factor. Yes? Because when we talk about scale factor, we talk about it or reference it as the lowercase k. Now the next part is our congruent angles. So we start off with angle A is congruent to angle what? E. Then we can say angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. Guys.
Didn't pay attention and don't listen to our conversation.
Guys.
That hard.
Guys. Now, all we're doing is matching up the congruent angles. Well, they're actually also listed in the statement itself. A, B, C, D, E, F, G, H. So we can line them up either way. Any question on finding the scale factor or our congruent angles? Are we good with both of those there? Now, the answer key is in the review sheet, and it's actually literally in the review sheet. It's in about the dead center. So, now, there is one last thing we have for this here, and that's our proportionality statement. Now, with a triangle, we have 3 sets of sides, but this one here is not a triangle, it's a quadrilateral, so we have 4. So for 1 and 2 on the review sheet, we'd only have 3 fractions, but here, since we have 4 sides, we're going to have 4. Now, we need to pick a side length, or a set of sides, to go first. Well, I can start off with AB, and the side that corresponds to AB is EF. Now, since I picked side length AB to go first, all the other sides on that figure have to go on top. So we could say BC is next, and it would be over FG. Then we can say CD over GH. And lastly, AD is over HE. Now we could flip in any of these letters because we could say AB or BA. Either one would work. So for these here, it's wanting us to find all of this. So we're wanting to find the scale factors, our congruent angles, and our proportional sides. Any other questions on 1 through 4? Any other questions on how we did problems 1, 2, 3, or 4? So problems 1 and 2 would be about the same, except we would only have 3 angles in 3 fractions, because it's a triangle. We only have 3 angles and 3 sides. Any other questions on 1 through 4? Questions on 5 through 9? Trying to find the missing side length. So if we look at number 7, if we're solving this here, and like most of the ones we solve for this here, we set it up with 2 fractions. Now in one of the fractions we're going to have x, and x is going to be over what? 40, because that's the corresponding side. And it's going to equal what over what? Yes, 5 over 25. Almost, it would reduce to 1/5. Any other questions on this here, or on how we set this up? So what would we do next? We would multiply both sides by 40. And we're multiplying both sides by 40 to get the 40 and 42 cancel out, telling us x is equal to so in the calculator we can say 5 over 25 times 40, and we get 8. So here at number 7, the answer is x is equal to 8. We can go on and look at number 8. So for number 8, we would set this up as our 2 fractions. We would have x over what? 12, because that's the corresponding side, is equal to 6 over 18. Because since we picked x over 12, well, we need 6 over 18 to correspond to it. The next thing we would do is multiply both sides by 12, because here the 12 and 12 will cancel. Now at this point, again, we could plug all this into the calculator. We can plug 6 over 18 times 12 and get 4. And that's it. That's all we have to do for these here. Any other questions on 6 or 5 through 9? We ready to move on? Okay. So this here, yes. Because if we're looking at the ratio of the perimeters, it's the same as the ratio of the sides. The ratio of the perimeter is the same as the ratio of the sides. And here it's only asking for the ratio. So we could say 8 over that's all it wants. How about 11? And 27 over 50 reduces to what? Nothing. It's actually 27 over 50. There's no common factors between them. And that's all we have to do for these here. Questions on 10 and 11? Yeah. Because it's just asking for the ratio. Find the perimeter of rectangle A and B from the given information. So do we want to look at 12 or 13? 12. How many perimeters are we finding? 2. If we're going to find the perimeter of A and the perimeter of B. Well, the perimeter of A is not too hard to find because we have 6, 10, 6, and 10. So it gave us all of them, and it is 32. So we have the perimeter of A, we just need to find the perimeter of B. Well, we said that the perimeters are proportional, same proportion as the proportions of the sides. So what we could say is that the perimeter of B over 32 is equal to almost 18 over 6. Because since we did B's perimeter over A, we need side length B over A. Now at this point here, we can multiply both sides by 32. These will cancel. So the perimeter B is and that's it. That's all we have to do for these here. Any other questions on 12 and 13? Okay. Are you ready for the next one? Determine if the following polygons are similar by angle. If so, write their similarity statement. So if two triangles are similar by angle, we need what? Two sets of that are congruent. So if I have two sets of congruent angles in the figures, then we can say the two are similar by angle. Is there one in particular that we want to look at? 14. So all I need is two angles, yes? In ABC and EFG, do we have two angles that are congruent? Well, we have one for sure so far, yes? We had that the measure, or not measure, that angle A is congruent to angle G. So we do have one set, but we need two, yes? So I can either find angle C or angle F. We just need to find one. F. Now, any three angles in a triangle add up to B, 180. Now, if we add 60 and 80, we get, and if we subtract 180 from 140, we get 40. So, does F and B match up? No. Is most likely C going to be 40? Because 80 and 70 is 150. And if we subtract it from 180, we get. So do we have two angles that are congruent? No. So can we say these are similar? Not similar. So those two are not similar. Any other questions on these here? We'll skip 15 for now. We can look at 17, yes. Now 17, these angles here in the middle are going to be congruent because of vertical angles. So we can say that angle ACB is congruent to angle ECD. Now we have to use three letters because, again, there's more than one angle at that vertex. We got to use three letters for it. Now there is another set of angles that are congruent. We could say angle D and A. This is going off of our alternate interior angles because those two lines are parallel. So we could say angle A is congruent to angle D because of our alternate interior angles. We could have, instead of A and D, we could have said E and B. But how many do we need? Do I have two angles that are congruent? Two sets of congruent angles, yes. So we can say triangle what? ECD is similar to triangle, yes. Because we're following the same path, because we said E and B are congruent. Since we started off with E, we have to start off with B. Then we went to C, and then finished this up. And how did we say that these were similar by? Angle, because that's what we used. Now, one thing I will tell you right now, let's see here, let's get a highlighter. Let's do blue. For the similarity statement, if you don't use the similarity marker, I'm going to mark off, because if you put congruent, because on a few of the homework assignments, instead of using this, you put this for the similarity statement. Again, that's congruency, not similarity. Because these triangles aren't congruent, they're similar. We're going to need this mark when we use the similarity statement. Not that one. Any other questions on 17? Any questions on 16? So we're good with 14 through 17? Questions on 15 through 18? And yes, the numbers did just repeat. (16, 17, 15, 16). Show that the two triangles are similar and write the similarity statement. So these, here it's guaranteed that they're going to be similar because it's asking us to show that they are. We can look at number 16. Well, are we given any side lengths? No, but we're given angles. So we know that angle B is congruent to angle L. Now we need to either show A and M or C and N. C and N, well, 85 and 60, if we add those together and then subtract from 180, is 145. And if we subtract that from 180, we get 35 degrees. So angle C is congruent to angle N. There's two angles, so triangle what? We just need to pick BAC. It's similar to triangle, so here we started out with B, which is 65, so the other one will start with L. Now the way you set up the similarity statement is I'm going to be checking each one of yours individually because again, there's multiple ones that we can have. 2, 4, 6. There's 6 different ways we can set this similarity statement up. So I will check to see how you set the first triangle statement up, and as long as it matches, the second one matches with it, you went in the same pattern, then it will be correct.
Do we have to write all that in green?
Yeah. Yep. Because the two angles, because we're showing it by angle, and the statement. Yeah. Show that the two triangles are similar, so this is our show, and then our statement and kind of our explanation for it. Questions on this here? Questions on 17 or 18? Let's look at problem number 19. Determine whether triangle JKL or RST is similar to ABC by side-side-side similarity. So all we need to do is show that the proportions for all three sides for two of these triangles are the same. Now, which one do we want to try first? JKL or RST? RST. So we can start off with side length 9 from ABC. What side length would we use for RST? 12. Now, 9 on ABC, is it the smallest, middle, or biggest, guys? Smallest. So for RST, we're going to pick the smallest side, which is 12. Now we can reduce this here to 3 over 4. Now what's another side from ABC? 15, which is, yes, over 20. Since 15 is the middle, we would take the middle side from it, which would be 20. And 15 over 20 reduces to 3 over 4. So that looks good so far. We found two that have the same proportion. And our last set aside would be 21 and 28, which reduces to 3 over 4. So ABC is similar to which triangle? Triangle. We don't have to check the other one because, again, it's saying it's one or the other. If we did check the other one, we would have 9 over 27, which would reduce to 1/3. We'd have 15 over 45, which would reduce to 1/3. So it looks like this could also work. So let's check the last one. 21 over 65 reduces to. So are all three the same? No. But 2 of them are, so if it's like that on the test, I would do all 3 just because the first 2 work. Doesn't mean the third will. So the answer is RST, since all 3 sets of corresponding sides reduce to 3 over 4. We could have done it the other way and had 12, 20, and 28 on top, but all of them would reduce to 4/3 instead of 3/3, 3/4. Any other questions on 19 or 20? Are we ready for the next one?
Yeah.
21 and 22, which one do we want to look at? ABC is similar to DEF. And we're wanting to solve for the value of x. So just like we did with the first one, we're going to have our 2 fractions. So we need to pick one of the side lengths that has x. EF, our x minus 1 over the corresponding side would be, which is 8. So half of the equation would be x minus 1 over 8. What would we use for the other half? Yes. So since x minus 1 is the one we chose first, we have to pick another side length, so either 15 or 8. I would pick 15 because its corresponding side is 10. It's just a number. If we picked 8, its corresponding side is 3 times x minus 1. We have 2 spots where variables show up. Here, it works out a little bit nicer. Any questions on how we set this up? What would we do next? Multiply both sides by 8. Here, the 8 and 8 would cancel, telling us that x minus 1 is equal to 12. And last but not least, we need to add 1, because we don't have x by itself yet. X equals 13. Yes? What were the instructions for these here? Find the value of x that makes the 2 triangles similar. Did we find the value of x that makes them similar? Do I need to plug it back in? No. So here, x equals 13. We can plug it back in if we want to see if the proportions stay the same, but we don't have to. Yeah. Questions on this here? Determine if the 2 triangles are similar. Show how they are similar and write their similarity statement. So this is our side, side, side proportionality. So we're either showing this by side, 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 angle, side, or angle, angle. We have one of these 3 that work. Which one of these do we want to look at first? 23? So 23 here. So 23, both of these have 3 sets of sides in both, yes? So we're not using side, angle, side, or angle, angle. We'll use side, side, side. So what we need to do is show that the 3 sets of sides are proportional. So give me a side length from one of the triangles. 5, and then its corresponding side is 10. And 5 over 10 reduces to 1 over 2. Now, since we chose 5 first, 7 and 9 have to go on top also, so that we keep the proportionality the same, if they are proportional. Since I chose 5 from here, we're going to use 7 and 9 from here also. Now, the side that goes along with 7, since 7's in the middle, we would want the side in the middle, which is And 9 corresponds to? So can we say these two triangles are similar? So we can say triangle SQR is similar to triangle EFD by what? By side, side, side. And that's all we need to do for this here. Any other questions on 23? Questions on 24 or 25? Or 26, I think there's one more. 26, 27, or 28? 27. Now, we're only given 2 sets of sides in both triangles, but we're also given a set of angles. Angle H. Now, for this here, angle H is shared in both triangles. Because the 2 triangles we have are this bigger one here and this smaller one here. So we also have 2 sets of sides. So if these are similar, they're going to be similar by side, angle, side. Now, one of the side lengths that we have is what? 21. Or do you want to use 121? So we can use 121 first. And the side that goes with it is 33. And we would see if we can simplify this here. And the other set would be over 21. Well, 121 over 33 reduce. 11 over 3. How about 77 over 21? So do we have 2 sets of proportional sides with a set of congruent angles in the middle? So can we say these 2 triangles are similar? So we can say triangle MNH is similar to triangle GFH by SAS. Side angle side. And that's all we need for that there. Any other questions on any of these here? So that's the whole test. So if there's no other questions on that there, so the test will be for tomorrow, except for those of you who won't be here. That'll be on Monday. And again, any of the missing assignments you have for Chapter 8, get them turned in tomorrow if you can, at the latest on Monday. I'll take them on Monday.